Okay, hi class. So, Assalamualaikum and good day everyone. Okay, so we already entered a new week, which is now we are in week 4. And for this week, we will enter the new chapter, which is chapter 3. And chapter 3 is about discrete random variables. So before we go deep into the subtopic for this chapter, I just want to what we got to say that, or to mention that here chapter 3 is something the content or the subtopic you already learned it before in probability chapter. This is chapter 2 and also a little bit chapter in chapter 1. Okay, we will go through this, then you will realize that you already learned some of that topics in the previous chapters. Okay, alright, so now I will proceed to the first slide here, which is the agenda. So agenda means the objective for this week, okay, or for this chapter lah. Alright, so for this week agenda, or maybe because if you refer to your teaching plan, so another one here, which is number 4 here, will be discussed on this week, but I will try to make it this week. Okay, I will try to make it or to finish it this week. Alright, so wait, I change it into band here. Alright, okay, so we can see here we have 4 items here. For the first one is about the concept of discrete random variable itself, okay, the title of the chapter, and then we will go to the probability and cumulative distribution functions. So we have probability distribution function and also cumulative distribution function. So this is what I mean that we already see it before. Okay, we already see the probability before it in chapter 2, is it? Okay, then for topics or the item number 3 is expected values and variance. So variance, okay, we already see it in chapter 1, and what's meant by expected values, so later on I will show you when it comes to these topics. And the last one will be the binomial, hypergeometric and Poisson distribution. So this is a type of distribution. Okay, so we have 3 type distribution for the discrete, and when we comes to another chapter, which is chapter 4 later, chapter 4 maybe next week, they have another type of distribution. Okay, alright, so now, okay, what's the discrete random variable means? Okay, discrete. Okay, discrete class, discretes. Okay, you just can imagine that they have no words random here. So discrete variables, we already learned actually what's meant by discrete, is it? In chapter 1, what's meant by discrete variable and continuous variable. So you need to recheck back the chapter 1. That's why I said that they will be related to something that you have learned before in chapter 1. Okay, this is quantitative data. Quantitative. Okay, so for when quantitative, we have discrete and also what? We have discrete and continuous, if not mistaken, is it? Kita ada 2, we have qualitative and also quantitative. So for the quantitative itself, we have another 2, which is we call it as discrete and also the continuous. So discrete, what is discrete means? Here is a countable. Okay, it's something that we can count. Okay, discrete is something that we can count. For example, a number of person, the number of car, the number of houses. Okay, right. So this is the example that you can see here. Okay, they have two example here. Number of students. Okay, so this is we can count number of errors on the page. Ada typo lah sini, so they have typo here. Okay, but they have the quantitative or countable data or numbers. Okay, we can count it. Alright, so now this is the example. Okay, now, alright, so we go to the number 2. Okay, item number 2 is probability distribution function and also cumulative. So we go first to the probability distribution function, or in the short, we just write it as PDF. Okay, so if you are deal, or you can, if you see later on, if they have word PDF, so PDF means probability distribution function. So in short form, okay. So the PDF for the discrete variable S is a formula that gives the probability, okay, give a probability. So you have dealing with probability before of observing each value of X. Okay, the keyword here is each value of X. Okay, each value of X. Alright. And this is the properties. Okay, the probability of X itself must be between 0 and 1 only. So if you can flashback ataupun you just you can refer back to the previous chapter, if you can see that all the probability that you count is 0 point something. Maksudnya it did not more than 1, and also it's not a negative value lah. So negative value means less than 0 lah kan. So your probability must be between 0 and 1 only. It can be 0, it can be 1, but most of the time it's 0 point something lah. Alright, 0 point something. And the total, okay, you can see the word here, the small all X. So all X mean, and this symbol summation means addition. Okay, all you add all, you sum all. Okay, sum all the probability. For example, let's say the question asks you to find the probability of blue marble, for example, and then the probability of red marble, and the probability of yellow number in a bowl. Okay, dalam mangkuk ada 3, blue, red and yellow. So all this probability, when you add all this, it will be give 1. Okay, must be 1, cannot be more than 1, must be 1. So that's why the probability must be between 0 and 1 only. The highest must be 1. Okay, alright. So actually this one is macam something like flashback lah. You dah belajar pun. I mean, you already learned the probability before. So this one is just something new, a little bit new, when we did not as PDF. So what's been by PDF again is a probability of observing each value of X. Okay, the keyword here, the highlight one here is each value of X. Okay, alright. So then this is an example, but before I go to the example, I want to brief to you about the meaning of CDF first. Okay, right, just now is PDF. Okay, just now is a PDF. So now this is CDF, or cumulative distribution function, CDF. So the CDF for the discrete variable blah 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 is a probability. So it's same probability, but it's a total. Okay, just now for the PDF is for each of it, which is 1 PX, maksudnya step 1. But this one is a total cumulative, and we do not as FX lah, capital FX, not a PX. And this is the equation, or the how we write. Okay, we can just ignore this. So it's mean by FX means the summation. Okay, class is summation. Kalau saya dah mention tadi, summation tu maksudnya hasil tambah setiap 1. So it's a summation of X here. You can see X here. Kalau you it's a little bit blur here, but maybe you can see, or you can refer to the PDF notes in Ulen. Alright, so it means that for example, we want to find F2. F2 means capital F. Oh, susah ni tulis. Wait. Capital F. So what does it mean? It means the probability of 2, which is PX, P2 plus P1. This is what it means. Okay, F2, okay, the probability of F2, not the probability, the CDF for F2 is equal to probability of 2 plus probability of 1. So it must be addition of these two. Okay, if you have or if the question asks you to find F3, for example, so what does it mean? What does it mean is equal to probability of 3 plus probability of 2 plus probability of 1. That's what I mean. Kalau usually, for example, maybe it will be equal 0 lah. Okay, right. Same thing lah for this one also, equal 0. Okay, if property of zeros have, so you just add on. So means that it's cumulative. It must be itself and then all the values before it. Okay, all the values before it. Okay, all right then. So this is what's meant by CDF. Okay, so then here's an example here. Okay, so I will go to another subtopic first. Okay, in this video I will explain first, then we will go to example later on. Okay, all right. So for the third one, which is expected values and variance. Okay, expected value and variance. So the first one here, expected value. So what's meant by expected value? So expected value here actually is mean. So maksudnya benda yang sama. Okay, it's the same thing. Expected value is a mean. So you already see it before, right? So this is a mu. Mu is a symbol for mean, and the formula to find the mean for this discrete random variable is not equal with the previous chapter. Tak sama. It's not equal. Totally not equal. Okay. So make sure you differentiate between mean that we will learn in chapter 1 and mean that you learn in chapter 3. So mean here, or mu, or expected value is equal to this. Okay, expected of x, expected value of x. And what does it mean? This one. So what you should do here actually, you can jump to this one lah. Terus, this one is just what we call the explanation lah, what's meant by expected value. So mu is equal to expected value, and how to find the expected value or mean, you need to sum all x, px. So what's meant x, px? So px here is your probability, and your x here is the probability, what we call the variable. Yes, the variable. Okay, so what we do here, you need to multiply first. You need to multiply x times px. For example, okay, I just shout here. Okay, later we will do the tutorial or what we call the example. So for example, x is 0, 1, 2, 3, for example, and the probability of 0 is equal to 0.26. Probability of 1, 0.8, for example. What we do is you need to multiply first. You need to multiply x with their probability. Okay, and then sum plus with the another one or in the next one, and then plus until in the end, until you finish. So that will be your mean. Okay, that will be your mean. And the second one is variance. So yeah, it's quite long here, but I can say that you just ignore this one. You just jump to this part. Okay, so this is the symbol for variance, right? Sigma square. Sigma square is equal to expected value of x square. Okay, class, careful. This one is x square, not x. It's x square. So means that you need to power 2 first, your x. Then baru you ni calculate. Okay, so x square, and then this is ex power 2, which is ex then power 2. This one means x square and then expected value, right? So this is two different things here. So make sure you identify well here. And what's mean by ex square? What means by ex and then power 2 is this one. So I can yes. Maksudnya this is the what we call the way how you can get your variance lah. So ex square, you need to x square first and then multiply with your px, and ex is your ex, so means that you need to find out your mean first. Okay, so this is equal, right? So then you substitute back into this equation. So this one will be your variance. Okay, and the third one will be standard deviation. So standard deviation is come from your variance. So you need to identify your variance first, and then baru you boleh solve standard deviation. So what's meant by standard deviation? Standard deviation is the square root of your variance. Okay, so kalau for example, if variance the symbol is sigma square, so for standard deviation the symbol is only sigma. Okay, so how to get your standard deviation is Oops. Okay, this one is sigma square class. Okay, so you need to square root it, so then you will get your sigma lah. Okay, just just square root. Okay, you get your variance and then you square root it. So that will be your standard deviation. So now, yeah, they have example here. And we have another one subtopic. Okay, if you are still remember, I said that it will be the type of distribution. So that one I will proceed to in the next video. Or maybe the next video tu maksudnya I will do the video for example first for this one. Okay, after that, yeah, another one video for the type of distribution. Okay, class, so I will see you in the next video. I will explain how to solve the examples in this two topics lah. Two topics means CDF, PDF, and also expected value and the variance. Okay, see you.